Okay, so what I thought I'd try and do today is to demystify some of the new techniques that are used at schools when teaching maths these days. And just to prove to you that it is actually an easy process, we thought rather than doing a fancy animation, we'd keep it simple with a marker and some paper. So let's say, for example, that we have two lengths of string. And let's just say, for example's sake, that the bottom piece of string is 20 centimetres long, and the top piece will make that 15 centimetres long. Now, obviously, the difference between these two lengths of string is pretty easy for most of us to work out. It's 20 centimetres minus 15 centimetres, which is 5 centimetres. Makes sense. And if we think about it, what we're really doing, if we were to remove that 15 centimetre piece, what we'd be left with is this length here, and that would end up being 5 centimetres. So what we're really thinking about doing is removing the shorter length. Another way to think about it is if we know that this point here is 15 centimetres, if we assume that's 0 to 15, we can actually count up from 15 to this point, which will be 20 centimetres. And from 15, 16, 17, 18, 19, 20, that will be 5 centimetres. Now that's just one example of how we can actually add on to perform a subtraction sum. And it might seem a bit odd counting forwards to do subtraction, but our brains are wired in a way that it makes it easier for us to finish the sum if we count forwards rather than counting backwards. So that's one example of how this sort of thing might work. A slightly more involved example, if we do a question, let's take, for example, 83 minus 47. Now we'll just do it the traditional way, and I'm sure that this is the way that most of you did it. Obviously we can't do 3 take away 7, so we borrow 1 from the 8. That leaves us with 7 there, and we give that 1 to the 3, and we have 13. 13 take away 7 is 6, and 7 take away 4 is 3, so we get an answer of 36. There's no problem with that. Now, the issue is that we don't really understand what we're doing here. We're simply borrowing a number and putting a 1 here, but we don't really understand the value of the numbers. So another way to think about it, going back to our example from before, if we were to draw a number line, okay, and we mark on it our two values. So we'll put 47 down the bottom here, and we'll mark on 83 up the top there. And then what we do is we count forward from 47 to the nearest 10, and we'll see why in a second. So that's going to be 50. The next 10 will be 60, and then 70, and then 80, and then we have 83. Now between 47 and 50, well that's 3 there. Between 50 and 60 is 10. 60 and 70 is 10. And 70 and 80 is 10. And between 80 and 83 we have 3. Now if we add together these numbers, we have 10, 20, 30. Okay, so 10 plus 10 plus 10. We start with the 10s because it's easier to add 10 than it is to add other numbers. So 10 plus 10 plus 10 is 30, plus 3 more, plus 3 more, give us 36. Now that technique is quite nice for a lot of students because it doesn't involve any carrying or borrowing of any sort, and therefore there's less likelihood of making mistakes. And again, what we're doing is we're counting forwards from a smaller number to a larger number, and because we tend to be better at adding than we are at counting backwards, it tends to be an easier technique for younger students to use. So there we go. Hopefully that's made this technique a little bit easier to understand, and we can link together that idea of counting forwards to do a subtraction sum.